Hello guys, welcome to the channel. Today we will discuss confusion matrix. So what is confusion matrix? A confusion matrix is used to check how well a classification model is performed. Okay, it compares actual values and real answers. Okay, my actual values and answers or outputs we are getting from the our model predictions. Okay, predicted values, model prediction. Okay, it compares this. Okay, it helps us to understand how many predictions were correct and where the model made mistakes. Okay. Now, suppose I have positive class is equal to 1, negative class is equal to 0. Okay. Then the matrix will be look like this. Actual 0, Tn, actual 1, predicted 0, Tn, predicted 0, Fn for actual 1, and predicted 1, Fp and P. What it means? True positive. Okay. TP means true positive. Means model predicted positive and it was actually positive. Okay. Next TN. True negative. Model predicted negative and it was actually negative. So these are two correct ones. Okay. Now false positive and false negative. FP. Model predicted positive but it was negative. Okay. Now, false negative. Model predicted negative, but actually it was positive. Okay. So these two are for calculating wrong and these are for calculating right. Okay. Means these two are for giving right output and these are two for giving the wrong outputs. Okay. Now, now for confusion, when we will build confusion matrix, we will get these four values. Okay, how much true negatives, how much false positive, how much false negative, and how much true positive. And these terms have these meanings. Okay. Now, on the basis of this confusion matrix, we calculate accuracy of the model. What is the formula of accuracy? Accuracy tells overall correct predictions. Okay, accuracy is equal to TP plus TN means all true means right outputs upon all the outputs. Right outputs means these two outputs upon all outputs. Okay, so this is the formula of accuracy. Now, precision. Precision means out of all predicted values, how many were actual positive? TP, we will take only true positive TP and upon TP plus FP, true positive and false positive. Okay. Same recall out of all actual positive, how many were correctly predicted? TP upon TP plus FN. TP means true positive and upon true positive plus false negative. Okay. And F1 is score. F1 is for balances precision and recall. These two. Okay. This is the formula of F1 is good. F1 is equal to 2 into precision into recall. Precision into recall upon precision plus recall. Okay. Got it? What is the meaning of these terms? Okay. So I will show you practically how we can use confusion matrix to perform these things, to calculate these things. Okay. First, I will show you how to calculate, how to create confusion matrix using Python. In Python, it is very simple. We can do by only scikit-learn. Okay, so we will see that on this placement dataset, I will perform confusion matrix. Okay, so now let's see how we can do it practically. Okay, first I will import some libraries. Import C1 as SNS. Okay. Now I will load my data set. data is equal to pd dot read slash csv. I will give the path of my csv file. This is my file. Copy path. Control V. I will check my data is loaded or not by checking first three rows. Okay, these are three. These are three are my first three rows. Okay. Now, now I will first divide the dataset into input and output. For input columns, I will basically store in X, and output column I will store in Y. I will I will use ilog, give me all rows and give me all column, but don't give me the last column. That is output column. Okay, data plus enter. Now my data gets divided. Okay. Now now I will now now I will basically I will divide the dataset into training and testing data. Okay. Now from scikit-learn dot I will import train test split. Okay. Model selection, import, import train test split. Okay. Now, now I will divide my data. I will take my all four variables for dividing my data set into training data set and testing data set. Equal to x, y. I will take test size as 0.2 for means it means 20%. I'm taking the testing data from the total data, random state is equal to 42. Okay. Oh, sorry. I forgot to call train test split. Okay. Now my data gets divided into training data set and testing data set. Okay. Now, now I will build the model from scalar dot sklearn dot linear model import import logistic regression. Okay. Now I will build the model. First, I will take an object LR. I will call logistic regression by this object. Now I will fit the training data into my model. X train comma Y train. Okay, it gets fitted. Now, now I will check my score, means accuracy. So 83%, 83.6% is my accuracy I got. This is what Accuracy means true positive plus true negative upon all the addition of all these four values of all these four terms. Okay, so I have already described what is the meaning of these terms. Okay, now now I have calculated the accuracy. Okay, now I will create a confusion matrix CF. Suppose CF is equal to first I will import this sklearn dot matrix import confusion matrix. Precision score, recall score, and last one F1 score. I will import all these four from a scalar. Okay. Now, okay. Simple is a spelling mistake. Now, I have imported all these things. Okay. Now, let's say I will create a confusion matrix. EF is equal to, let's see, I will call this confusion matrix. I will take y test lr dot predict x test. Okay, x test. Right now, I will see it. Now, see, I have created confusion matrix. Now, we got all four values. What is the meaning of these four values? 1670 is your true negative. True negative. True negative means model predicted negative and it was actually negative. Okay, so this is the correct answers which I got 1670. Now 4 4 is equal is your FP false positive means model predictive positive but actually it was negative. Okay, so there are total four values like this. Okay, 324 is your false negative means model predicted negative but actually it was positive. Okay, so how many values are like this? 324 values are like this. This is very high value, high number of values. Okay, 2 2 is your true positive means model predicted positive and it was actually positive. So there are only two values for this. Okay, so this is a quality of like a poor model. Okay, this is not a good model. Okay, this is what I got from creating confusion matrix. Okay, now, now, now I will calculate all these things: precision score, recall score, and F1 score. Okay, first I will give a markdown that for a good model, all these values should be high. Precision score, recall score, F1 score, all these values should be high for a good model. Okay, I will write this. All these values should be high for a good model. Okay, I will give a markdown, shift plus enter. Okay, now, now I will calculate all these things. Okay, I will take this precision score, sorry, same I will take y test. I'm comparing from what? Test and what my model predicts. LR dot predict for X test X means our training, which I have basically, what are my X test? My X test is the testing value of my input call. This is what my X test. So what is my model is giving prediction for those X test. X test into 100. Only 33.33. This is very low. So this is a sign of this is not a good model we have. Okay. Again, now this time I will calculate recall score. Only 0. See, I have multiplied it by 100. After that also I'm getting 0.61. Again, this is very low. So this is not a good sign for my model, which means this is not a good model we have built, right? Now last one I will calculate F1 score. I've already described these terms: true negative, true positive, false negative, false positive, and all these things. Accuracy, precision score, recall score, right? Now I will again take this. Now see, only 1.20. This means if these values are not high in classification algorithms, then this model is not good. Okay, these values should be these all values: accuracy, precision score, recall score, F1 score. All these four values should be high. Then only we will think we will get a good model. Okay, so we got the we have discussed the confusion matrix topic, and all these confusion metrics, precision score, accuracy, recall score, we have discussed. Okay. Now, in next video, we will see how to deal with imbalanced data set. Okay. Thank you.